Good evening, everyone. I hope you are all doing fine. So, is my voice audible? Then we can start. Say yes or no. You can unmute yourself or say in the chat box. Okay, fine. So, yeah, I have been told that from today you are the students from Hyderabad region will be joining. So, welcome to all those students. Uh, we will be doing. We will be doing we will be continuing with indefinite integration. Probably this will be the last lecture for indefinite integration, and from next means from tomorrow we'll be doing definite integration. So let me just tell you what we'll be doing today, or where are we. We have completed partial fractions. We have completed partial fractions, all the three types. So from today we'll be, as you can see on the screen, you will be starting with improper rational functions. So let me introduce myself first. My name is Keval Parmar, and I am a professor of mathematics. So before moving forward, I hope you all are also we'll get to know each other as the lecture proceeds. But welcome all. Let's start today's session without any further delay. Got it? Chalo. So first, let me tell you what are improper rational functions. Now, do you know what are rational functions? Rational functions are basically polynomial upon polynomial. So those are rational functions. Now, then in rational functions, we have two types: proper rational functions and improper rational functions. Proper rational function means degree of numerator is less than degree of denominator. And improper rational functions is degree of numerator is greater than degree of denominator. Got it? So these are called improper rational functions. For proper rational functions, we basically use partial fractions. Now for improper rational functions, as I would like to say, we use the rule divide and rule. Divide and rule means like बचपन में क्या था ना, क्या ऐसा division 5 divided by 2 and all. So similarly here we'll divide the polynomial, and finally उसके बाद your favorite formula कौन सा, डिविडेंड इज इक्वल्स टू डिवाइजर इनटू कोशेंट प्लस रिमाइंडर. तो एनसीईआरटी में बहुत किया था हम लोग ने 9th-10th स्टैंडर्ड में. Got it? So let's see, that formula is here given, that the rational function can be expressed as quotient plus remainder upon g of x. So what I'm trying to say will be more clear if we do some example. So as you can see, we are not doing integration example. I have just taken a rational function. This rational function, numerator का degree क्या है? 2. What is the degree of denominator? 2. Means both of the degrees are same. That means it is a improper rational function. What we do, we use divide and rule. So divide and rule क्या बोलते हैं? कि एक्स स्क्वायर माइनस 8 को डिवाइड कर दो एक्स स्क्वायर माइनस एक्स माइनस 6 से. तो इफ यू नो दिस, क्या आएगा यहाँ पे? विल यूज 1. तो दिस इनटू 1 विल बी एक्स स्क्वायर माइनस एक्स माइनस 6. फिर हम लोग क्या करते हैं? सब्ट्रैक्ट करने पे सबकी साइन क्या हो जाती है? चेंज. तो एक्स स्क्वायर माइनस एक्स स्क्वायर खत्म, यहाँ पे प्लस एक्स बचा, और -8 + 6. -8 + 6 is -2. So here this is quotient, right? Na? This is remainder. This was my numerator, or as you can say, dividend. But let's not confuse. Actually, I get confused between dividend and divisor. So I basically use numerator and denominator. So numerator, and this is denominator. So what formula we know? Which formula हम लोग को पता है? We know that numerator is equals to डिनोमिनेटर इनटू कोशेंट प्लस रिमाइंडर। अभी मैंने अगर ये इक्वेशन को डिवाइड कर दिया किससे, डिनोमिनेटर से, तो अगर मैं डिनोमिनेटर से डिवाइड कर दूंगा तो यहाँ पे डिनोमिनेटर एंड डिनोमिनेटर कैंसिल हो जाएगा, क्या बचेगा, न्यूमरेटर अपॉन डिनोमिनेटर, विच इन केस आर केस में क्या है वो, एफ ऑफ एक्स अपॉन जी ऑफ एक्स, जहां पे अपना एफ ऑफ एक्स कौन है, एक्स स्क्वायर माइनस 8 अपॉन एक्स स्क्वायर माइनस एक्स माइनस 6 विल बी इक्वल टू, ये क्या है, कोशेंट प्लस रिमाइंडर अपॉन डिनोमिनेटर। दैट मीन्स अपना कोशेंट कौन है, 1, तो 1 प्लस रिमाइंडर कौन है, एक्स माइनस 2 अपॉन डिनोमिनेटर, डिनोमिनेटर कौन है, एक्स स्क्वायर माइनस एक्स माइनस 6। तो दैट मीन्स मैं ये वाले फंक्शन को जो मुझे दिया है उसको कैसे लिख सकता हूं, उसको मैं लिखता हूं 1 प्लस एक्स माइनस 2 अपॉन दिस। नाउ इसके बाद हम लोग क्या करेंगे, ये जो फंक्शन बचा इसमें न्यूमरेटर का डिग्री देखो 1, डिनोमिनेटर का डिग्री क्या है 2, सो दिस इज अ प्रॉपर रैशनल फंक्शन, प्रॉपर रैशनल फंक्शन। प्रॉपर रैशनल फंक्शन मतलब वी क्या यूज करेंगे हम लोग यहाँ पे, यहाँ पे क्या यूज करेंगे हम लोग, पार्शियल फ्रैक्शन। आई होप इट इज क्लियर टिल नाउ। यू कैन टॉक, अगर बीच में कुछ डाउट है सो यार यू कैन टाइप इन चैट बॉक्स और रेज अ हैंड इफ यू आर लाइक शाय और समथिंग टू स्पीक, सो यू कैन से। यहाँ तक क्लियर है तो यू कैन गिव मी अ थम्स अप प्लीज। एनीवन, एनी डाउट्स टिल हियर और इज इट क्लियर? Should we move forward? I would like that to make the session more interactive, as much interactive as possible. So if it is clear, you can say yes, no. Doubt है क्या है? हेलो, चलो चलो, इतना शर्माओ मत, यू कैन से समथिंग, yes, no, all good. Okay, fine, fine, super. चलो, let's start now. Let's look at the actual question. Question कैसा आएगा? So this is the question. So similar ये हम लोग जो पहले किया है वो similar to previous question. तो न्यूमरेटर, लेट्स लुक एट न्यूमरेटर का डिग्री 2, डिनोमिनेटर का डिग्री ऑल्सो 2। हम लोग क्या करेंगे, विल यूज डिवाइड एंड रूल। तो करो, डिवाइड करो, यहाँ पे क्या आएगा, एक्स स्क्वायर प्लस 1, व्हाट विल कम हियर एक्स स्क्वायर माइनस 5x प्लस 6, सेम 1 ही आएगा मेरे ख्याल से। तो यहाँ पे आएगा एक्स स्क्वायर माइनस 5x प्लस 6, विल सब्ट्रैक्ट माइनस प्लस माइनस, ये एक्स स्क्वायर कैंसल, यहाँ पे क्या बचा 5x प्लस 1 माइनस 6, तो माइनस 5। तो दैट मीन्स आई कैन राइट, फॉर्मूला क्या था, न्यूमरेटर अपॉन डिनोमिनेटर इज इक्वल्स टू कोशेंट प्लस रिमाइंडर अपॉन डिनोमिनेटर, यही था ना, numerator and quotient plus remainder upon denominator. So in our case, I can write x square plus 1 upon x square minus 5x plus 6 as quotient क्या है 1. This is the quotient, right? So 1 plus remainder is 5x minus 5 upon denominator क्या है x square minus 5x plus 6. So that means this question will now become is equals to integration of 1 plus 5x minus 5 upon, यहाँ पे डिनोमिनेटर को आई कैन फैक्टराइज, डिनोमिनेटर को मैं क्या लिख सकता हूं, x माइनस 3 इंटू एक्स माइनस 2 dx. गॉट इट? दैट मीन्स यह हो जाएगा इंटीग्रेशन ऑफ 1 dx प्लस इंटीग्रेशन ऑफ 5x माइनस 5, स्प्लिट कर दिया एडिशन में, upon x minus 3 into x minus 2 dx. It is clear till here? So इसका तो डायरेक्ट पता है, इसका करने की जरूरत नहीं है. So let's look at this. ये वाले को देखते हैं. Let's look at this. Here this is partial fraction. What can I do here? I can simply write 5x minus 5 upon x minus 3 into x minus 2 as a upon x minus 3 plus b upon x minus 2. So if I take LCM, denominator दोनों side से, denominator will get cut from both the sides. So I'll get a into x minus 2 plus b into x minus 3. यहाँ तक clear है? चलो, let's move forward. What we can do here, if you know what I do for a, now I want a here. So a चाहिए, मतलब b को क्या होना पड़ेगा? 0. So for a, put x is equals to 3. So if I put x equals to 3, here on the left hand side, what I'll get? 15, 5 3s are 15 minus 5, 10 is equals to a into 3 minus 2, 0 or 1 plus b into 0. So यहाँ से a की वैल्यू क्या आ गई? a is equals to 10. Now let's say for b. So for b के लिए क्या करेंगे हम लोग? इसको 0 होना पड़ेगा. अभी इसको 0 होने के लिए x की वैल्यू क्या पुट करनी पड़ेगी? What will be the value of x? It will be 2. So that means 5 2s are 10 minus 5. 10 minus 5, 5 is equals to a into 0 plus b into minus 1. That means what is the value of b? It is minus 5. Clear है यहाँ तक? Any doubts till here or it is clear? Please you can say clear till here. Yes, no. Come on guys, कुछ तो you can give me some response. Otherwise, I'll also get bored. It is clear till here? Yes, no, come on. Clear, clear, clear. Yes, no, you can say something. Hello. Clear. Good. Super. Chalo. So here I can write now my integral as substitute a and b here. So if I substitute a and b here, what will my question become? My question will become integration of 1 dx, which we all know, plus integration of a. We'll use this na in place of this. So I can write 10 upon x minus 3 dx minus or plus integration of minus 5 upon x minus 2 dx. Right? And these both integrals are very simple. अभी तो सबका इंटीग्रेशन पता है. वन का इंटीग्रेशन इज x प्लस 10 तो कांस्टेंट है, इट विल बी कम आउट, एंड इसका इंटीग्रेशन ln mod x minus 3 minus 5 is constant, it will come out, and इसका इंटीग्रेशन ln mod x minus 2, and last में what we should not forget, it's plus c. So this is my answer. I hope it is very clear. What we do in improper rational functions, we use division, divide and rule. Divide and rule, you must have like listened somewhere. History में पढ़ा होगा ना, divide and rule. So that only we use divide and rule, and then we convert into proper rational form. And after proper rational form, what we do, we use partial fraction. So it is very simple. So here the rational functions integration is over, like till here. Rational function integration में we have two part types. We always use partial fraction. Improper में we use divide and rule. Correct. So now let's move on to next part. Next part is the integration by parts. Integration by parts. What is integration by parts? You know, there was a rule like in differentiation we had the product rule. UV rule जिसको बोलते थे हम लोग. U derivative of V plus V derivative of U. So there was no such rule in integration. But here in integration by parts, we develop that rule. That means basically we use integration by parts when the integrand means the function is expressed as the product of two different types of functions. Like suppose say we have x into ln x. Integration of x into ln x dx. X into ln x dx. This is a simple example. So in such types, we use the product rule. X and ln x are getting multiplied. So what is the rule basically, or the formula? Formula is integration of u into v dx is equals to, you must know all this. U integration of v minus integration of derivative of u into integration of v dx. Where it is essential to make proper choices of u and v. If you remember, in differentiation, we do not choose who is u, who is v. We just took randomly. कोई भी u ले लेते हैं and कोई भी v. But in integration, we must choose u and v very carefully. And here is the biggest hint. V must be integrable. V must be integrable. And u must be differentiable. This is a basic choice. Now, throughout the years, we have developed a method to select u and v. So what is the method? The u to be selected will be the one which comes in the order of Liet. Now you must all know these rules. What is the Liet rule? Or you should know Eilert. Many a times we use Eilert. Basically, when I was studying, I used Liet. So from that time, I always used Liet. I never used Eilert. So it's no problem. Both are same. So we can use Liate, Liet rule. Liet rule means whichever function from these comes first, that will be my u function. So for u. So what is L? L is a logarithmic function. I is the inverse trigonometric function. A is the algebraic function. T stands for trigonometric function. E stands for exponential function. Correct? Let's try a very simple example. You have to remember the Liet rule, Eilert rule. So here it is. Next, we have to find integration of x into cos x dx. Here x and cos x are getting multiplied. So according to Liet rule, Liate, हम लोग के पास कौन से we have x means algebraic, cos x means trigonometric. अबे out of these two, which came first? Algebraic one came first. So that is x is my u, cos x is my v. So likewise, what was the formula? It was u integration of v minus integration of v into derivative of u. Correct? So what is integration of cos x? It is sin x. So that will be x into sin x minus integration. What is integration of cos x? It is sin x into what is derivative of x? It is 1. So basically what I get is x sin x minus integration of sin x dx. And what is integration of sin x? Integration of sin x is minus cos x. So that minus and this minus will become plus. So plus cos x and plus c. This is my answer. It is very simple. You just need to identify u and v and then again use direct formula. Now this second question is a good question because here we don't have other function. Like we have only one, which is log x. There is no product of two functions. But as you may know, we can write this as 1 into log x. Correct, na? I can write it as 1 into log x. So let's check who will be u and who will be v. So according to Liet or Ilet, you can say any. This is algebraic. One is algebraic and logarithmic. So which comes first? First is log function. So this will be u and this will be v. So repeat after me. What is the formula, please? U means log x into integration of v dx minus integration of v into derivative of u the whole dx. I hope it is clear. Now please see now from the next question I will skip this step. Like we'll directly skip this step and we'll that make us faster. So this is the last time I'm doing this step. So that will be log x into what is integration of 1 x minus integration of 1 is x into derivative of log x dx. Here x and x will get cancelled. If I rearrange this, I will get x log x minus integration of 1 dx. What is integration of 1? It is x log x minus x plus c. This is my answer. Simple. Just we need to figure out u and v and then we can easily get answer. Got it? Now let's proceed into next. This is interesting. Now let's use again Liet. What is Liet? Liate. Here we have algebraic and trigonometric. So who came first? Algebraic. So that means this is my u and this is v. What is the formula again? U x integration of sec square x dx minus integration of sec square x dx into derivative of u the whole dx. What is integration of sec square x? It is tan x minus integration of tan x and derivative of x is 1. So I am not writing 1. Got it? So and what is integration of tan x? Do you remember integration of tan x? It will be x tan x minus log mod sec x plus c. Simple. This is my answer. I hope it is clear. Got it? So if you have any doubt till here, you can say, or if you have clear, just say yes, sir. So we'll move forward. Got it? Clear till here? Till UV rule or till integration by parts? Clear na? Everything? Hello? Bolo, bolo, please say something. Yes. Okay, okay. Very good. Chalo. So let's move on to next, which is also integration by parts type, which is this. You must have known this. Right? A special form of integral here. If anywhere I see this format, this is the format. What is the format? That bahar, outside we have e raised to x, inside we have function plus its derivative. inside we have function plus its derivative. If we see this format, outside e raised to x, inside function plus its derivative, then we can directly write it as this. Answer means we can directly write the answer as e raised to x f of x plus c. Now, let's look at the proof. The proof is very simple. We use substitution. So let e raised to x f of x is equals to t. Now, if I differentiate with respect to x, so here I need to use UV rule. So e raised to x into derivative of f of x, which is f dash of x plus f of x into derivative of e raised to x, which is e raised to x, is equals to dt over dx. Now on left hand side, I can take e raised to x common. What will I get? F of x plus f dash of x, and I multiply cross multiply dx, so I'll get dx is equals to dt. So now my integral will become, this integral will become integration of dt, बस इंटीग्रेशन ऑफ dt, ये पूरा e raised to f of x plus f dash of x dx क्या हो गया? dt, that is 1. So what is integration of 1? It is t plus c. Now it's time to resubstitute. What was t? T was e raised to x into f of x plus c. So this is my answer. This is a very, very, very important form, because many a time there are direct question asked in JEE mains on this form. Direct means like it'll take you like 15 to 20 seconds to solve. But direct it is asked. We'll see the questions asked in JEE next slide. In the next slide, we'll see which questions were asked. But it was direct question. Direct. So we just need to remember this form. Very important. You can mark it, or I'll mark it. Very important. Okay, so let's look at the questions here. So for this, as you can see, the format is of that type. So I can say integration of e raised to x, tan inverse x को function मान लेते हैं, plus what is derivative of tan inverse of x? It is 1 upon 1 plus x square. So that means it is f dash of x. In place of tan inverse x, we have f of x, and in place of this, we have f dash of x. So if you remember what is the answer, we can write directly e raised to x into f of x plus c. That means in my question, my answer will be e raised to x into tan inverse of x plus c. This is my answer. Chalo, here anyone would like to try directly? What will be my answer? I'll give you 10 seconds. 10 seconds are enough, I guess. You can say in the chat box what will be the answer for that. Chalo, you can say. What will be my answer for the second question? Chalo, it is very simple. Superb. Very good. So here, as we can see, this is f of x and this is f dash of x. So this is a very simple question, which is answer will be e raised to x into 10x plus c. Superb. Very good. So let's try some interesting question. This is also warm up. Okay. Now let's look at this. Now believe me, the main problem in solving these types of questions or solving integration questions is to click which format is it. Like if you can understand, we are doing this question under this heading, a special form of integral. So it is like a human tendency ki we know ki we have to use that special form. But sometimes directly if the integration question comes, then we may not click ki, this is the special form, or this is the form of e raised to x f of x plus c1. So that is the main part. But since now you know we are doing this question under the format of the special form, that means this will be done by that form. So I hope you are getting me what I'm trying to say. So that is the main thing with integration. So I'll give you 30 seconds to do whatever you can do here, to click, or you can say to think this question. After that, I'll proceed. I'll write the form, the special form here. If you forgot, integration e raised to x f of x plus f dash of x dx. This is my form. If you can say this, then I'll be very, very happy. Yeah, what we can do here. If you got if you can click it. If not, then I'll do it. Don't worry. Two e raised to x into x plus 1. E raised to x upon x plus 1. Yeah. The first one was wrong. Second is right. Very good. Very good. 2 e raised to x will nahi aayega. There will no be 2 e raised to x. Chalo. Most of you have tried. So let's see how I can do. Basically, here e raised. So basically, I need to convert this into this. I hope you are getting it. I need to convert x upon x plus 1 the whole square into this. So for that, what I'll do is I'll write e raised to x into, I'll add 1 and subtract 1. So x plus 1 minus 1 upon x plus 1 the whole square. So after this, I will split the numerator. So if I split the numerator, I will get 1 upon x plus 1 minus 1 upon x plus 1 the whole square. Now, as you can see, I can further simplify this as integration of e raised to x 1 upon x plus 1 plus minus 1 upon x plus 1 the whole square dx. Now, if you can see clearly, this is f of x and this with negative sign is f dash of x. You can try. If I differentiate this, I'll get this. Okay. So now it is very simple. Now I can easily write the answer was e raised to x into f of x plus c. So very correctly said by one of you. It is e raised to x plus c. Very good. This was a nice question. Let's move on to the next. Now, next is we are completed with this special form. Now there are other standard forms which are these. These are basically the three formulas. Very big formula and difficult to understand. But somehow I learned it. Like I by heart this formula somehow. कैसे तो करके I did it. I hope you also did all these three formulas, 1, 2, and 3. Basically, these are also formats. What is the format? Under root of a square minus x square, under root of a square plus x square, and under root of x square minus a square. And these are the answers. I hope this you all know. So if yes, then we can proceed with the questions. Now, let's look at the questions. Here. ये तो डायरेक्ट ही है. This is basically the proof, you know, like if I have to prove the first formula, this formula I have to prove. So how will I prove it? Now believe me, these proofs are asked in the NCERT board exams for 4 marks or 3 marks. So it is very important to learn this. Are very simple. We just need to use the by parts rule, like u into v rule. So as you can see, similar to log x. You remember log x? Log x mein we had only one function. So we multiplied with 1. So I can write this as integration of 1 into under root of a square minus x square dx. Now, who will be u? Who will be v? Both are algebraic. Both are algebraic. So, in such cases, remember, u should be derivable and v should be integrable. When we did integration by parts, this was very important heading. V must be integrable, u must be differentiable. So in our case, according to this logic, we can take this as v and we'll take. So if I use the formula, I'll get u under root of a square minus x square into integration of v minus integration of v into derivative of under root of a square minus x square dx. So here I'll get under root of a square minus x square into x minus integration of 1 is x upon derivative of root x 1 upon 2 under root a square minus x square, but there will be chain rule. So I need to multiply it with minus 2x dx. Correct? So from here, this will get cancelled. 2 and 2 will get cancelled. And I'll rearrange this x under root of a square minus x square. Correct? I hope I'm not wrong. This minus and this minus will be plus, and I'll get integration of x square, x into x square upon under root of a square minus x square. Now, does anyone know how to integrate this function? Second part. If not, what I'll do, I'll add and subtract a square. So a square minus x square plus integration of, or okay, let's keep it as minus of minus x square. It will be better. है ना? So I'll add a square and I'll subtract a square upon under root of a square minus x square dx. Now I hope you all know this. Ki x upon under root of x. If we rationalize, I'll get root x. Right now? I hope I am doing right. Is there some mistake here? So here I'll split the denominator. So I'll get x under root of a square minus x square plus. According to this logic, I'll get under root of a square minus x square dx after splitting minus integration of a square upon under root of a square minus x square dx. Now remember, if I take this as I, so you can see the same question appeared here. So basically, what is this? This is I. Correct? Here it was minus. My mistake. It is I. So in left hand side we had I, or a minus I, left hand side में जाके plus I. So in I plus I will get 2I is equals to x under root of a square minus x square. If I open the bracket, the minus, this minus and this minus will become plus. Plus a square is constant bar integration of 1 upon under root of a square minus x square dx. Now 2i will be equal to x under root of a square minus x square plus a square. This is the standard integral. What is the integration of this? It is sine inverse of x by a plus c. Now I wanted the value of I. So that means if I wanted value of I need to bring 2 on right hand side. So I will be x by a square minus x square plus a square by 2 into sine inverse of x by a plus c. This is my answer. And you can verify it. This was the same here. X by 2 under root of a square minus x square plus a square by 2 sine inverse of x by a plus c. So this proof comes for 4 marks in the board. So it is important to remember this. Similarly, you can do these proofs, the second and third one. Same thing you'll do. U into V rule, multiply it with 1, use by parts, and you'll get the answer. So let's look at the question, right? Here. So integration of under root of this. So I need to open the bracket, I guess. If I open the bracket, I'll get, what I'll get here? 7x minus, 7x, right? Minus x square 3x dx, right? So if I simplify it, I'll get under root of minus x square, it is quadratic, right? 7x plus 3x plus 10x minus 21. So here it is important now. Now in this case, do you remember what we do if we get a quadratic? We use completing square. So we'll take this quadratic and we use completing square. So for completing square, the leading coefficient, x square ka coefficient should be 1. So that's why I took minus common. I'll get x square minus 10x plus 21. Now I'll add and subtract. What? I'll add and subtract 25. So I added 25 and I subtracted 25. This is the completing square method. So minus this. What is this? This is x minus 5, the whole square, and minus 25 plus 21, which is minus 4, and minus 4. So I can write minus 2 square. That means if I open the bracket, if I took minus inside, I'll get 2 square minus x minus 5, the whole square. That means in place of this, I can use this. So my integration will become integration of under root of 2 square minus x minus 5, the whole square dx. I hope it is clear. Now this looks like integration of under root of a square minus x square dx, where in place of a we have 2 and in place of x we have x minus 5. Do you remember the formula? It was x by 2 into under root of a square minus x square, means the same, 2 square minus x minus 5, the whole square, my plus a square by 2 into sine inverse of x by a plus c. So if I try to simplify this, this will be x minus 5 by 2. Now please note this one came from here, and this came from here, and this came from here. So that means I can say that this quantity and this quantity both are same, or you can simply open the bracket and try. So here I can write minus x square plus 10x minus 21, correct? Plus 2 square by 2 means 4 by 2, which is 2 into sine inverse of x minus 5 by 2 plus c. This is my answer. I hope it is clear now. If this is clear, please say, and we can move on to the next question. Got it? I hope it is clear, very clear. Any doubt you can ask now. Chalo. Yes, no, you can say, come on, guys. It's clear, or should I give you a minute to go through the question? You can go through it again. It's here only. Clear, clear. All good. I'll give you 30 seconds to go through the question. Please go through it. Come on, guys. Yes, no, you can say something. Please don't make the lectures. Okay, okay, done, barabar. Yeah, it's a request. Please don't make like I keep talking and talking and talking. There is no interaction from your side. Okay, you raised an hand. So, what is your doubt? Yes, someone raised a hand. Any doubts? Yes, yes. Ask your doubt. Anand. Is your Anand right now? You can ask your doubt. What is your doubt? Nothing. Okay, okay, fine. Chalo. So I hope it is clear now. Next is some special integrals. Now I hope ki like I don't think okay, we'll do it. Some special integrals. So we can do one question now about this. So let's see. This is again a format. What is the format? The format is 1 upon a sine square x plus b cos square x plus c, where a, b, c are constants. A, B, C are constants. So if this format comes, to solve this format, the method is very simple. Here I have given the 4 steps. What are the 4 steps? Divide numerator and denominator by cos square x. We'll avoid with sine square x. We'll always divide by cos square x. In denominator, replace sec square x by 1 plus tan square x by using the identity. Then put tan x equal to t. We are avoiding the second part, right? And after this, my integral will convert into this form. And this is very easily integrable format. Got it? What is step 1? Step 1, step 2, step 3 are important. Divide numerator and denominator by cos square. Second is, in denominator, put sec square x equal to 1 plus tan square x. And lastly, put tan x equal to t. Let's try one question. A very simple question. Here. This is the same 1 upon a sine square x plus b cos square x plus c, where a is 2, b is 5, and c is 3. I hope it is clear. So what is the first step? First step, we divide numerator and denominator by cos square x. So, ऊपर में if I divide by cos square x, so 1 upon cos square x, I will get sec square x. Niche, here I'll get 3 upon cos square x, means 3 sec square x plus 2 sin square x upon cos square x, which is 2 tan square x plus here 5 cos square x upon cos square x will get cancelled and I'll be remaining with 5. What was the step 2? Step 2 में this term in denominator में sec square x, so we have to convert into tan square x. So I can easily convert it into tan square x by writing as sec square x is 1 plus tan square x plus 2 tan square x plus 5 dx, right? So if I simplify the denominator, I will get sec square x dx upon 3 tan square x plus 2 tan square x. What is 3 tan square x plus 2 tan square x? 5 tan square x. Correct? And 3 plus 5. 3 plus 5 is 8. Now, what was the third step? We are done till second step, right? We are done till second step. What is the third step? Put tan x equal to t. So let's put tan x is equals to t. Now I'll differentiate it with respect to x. That means I'll get sec square x dx is equals to dt. So my integration will become dt upon 5t square plus 8. Now I can very much write it as 1 upon root 5t का square plus root 8 square dt. Do you remember this form? This is integration of 1 upon x square plus a square dx. What was the answer? It was 1 by a tan inverse of x by a plus c. Here in place of x we have root 5t and in place of a we have root 8. Got it? So if I apply this formula, I'll get 1 upon root 8 into tan inverse of root 5t by root 8 plus c. Now, here we will also write root 5, 1 upon root 5. Now, can anyone tell me why 1 upon root 5 came here? Why I wrote 1 upon root 5 here? You can tell in the chat box. Why I wrote 1 upon root 5 here? This is my complete answer. But I need to know there is, in the formula, there is no 1 upon root 5. There is only 1 upon a. So why I wrote root 5? Come on. Why I wrote root 5? Anyone? Why I wrote root 5? It is very simple. It is basic integration. Like in the first lecture, you must have studied this. Why I wrote root 5? Oh, I suppose, I hope you understood the question, right? So if you understood the question, you can say, why did I write root 5? Come on. You all know. You have studied exactly in the first lecture of integration. You can say here. Anyone? No one? Okay, no issues. If you remember, we divide by coefficient of x. So that's why I wrote root 5, if you remember. we divide by coefficient of x whenever there is a linear term. So basically this is 1 upon root 40 into tan inverse of root 5t upon root 8 plus c. Now we have to resubstitute. What's t? It was 10x. That means root 5 10x. This is my final answer. Got it? I hope you understood it. So we are done with the time. So the lecture is over. I hope you understood this and understood how to use the formula, how to approach the questions from integration, the special formats, and we'll meet next time. Next time means tomorrow, and we'll be doing definite integration, or we'll be starting with definite integration. So I hope you will revise or something like that. We'll do some questions on definite integration and continue with that. So till tomorrow, see you soon. Bye bye. Take care, everyone.